Hey, what's up guys? This is Akshay from AS Learning and today I'm back with another end-to-end ML deep learning project, and in this project we will be doing COVID detection from images using CNNs. So for dataset purpose, I've referred this dataset of Kaggle. So I found it at a link by Pranav Raikote, and in this dataset, in its original form, we had three classes. One is COVID, normal, and pneumonia. So it was a three classes classification problem on image dataset. For simplicity purpose, what I've done is I've eliminated this pneumonia folder entirely, and on I've kept the dataset with two classes, that is COVID and normal. So I'll be sharing this link in my description, and you can download this dataset from the link. Okay, so let's have a look at the dataset on which I've trained my CNN. So I have two folders here. One is test set and one is training set. In training set, we have two folders, COVID and normal. In COVID, I have all the x-rays of patient who are corona positive, and in normal, I have all the x-rays of the chest of the patient who are corona negative. Okay, and in the similar structure, I have it for test also. Okay, cool. Now let's go towards my code. Now what I've done here is I have solved this problem by building a normal CNN architecture. Okay, future announcements would be definitely using transfer learning and how VG16 and other pre-trained model can be used, but for now in this tutorial I've built a CNN and used it for classifying whether the x-ray is COVID positive or not. Okay, so let's first start with the imports. I have imported all the required packages, that is sequential 2D, sequential COV 2D, max pooling, flattening, and dense. I have initialized a sequential object, and in my first layer of convolutional neural network, I have added 64 filters, that is 64 kernel of the size of size 3 into 3, and I have kept the input shape as 64 into 64 into 3. Now this input shape is the shape of my images in my training set. Okay, now sometimes what happens is images can be of different sizes. Now what happens is if I've kept here 64 by 64 by 3, so it would only pick the dimension of 64 by 64 by 3 and it would be used in the training set. Okay, I have kept the activation function as ReLU here. So as we know that a basic CNN architecture works in this way, that we have some CNN filter layers, then you can add pooling layer if you want, then you can have as many CNN plus pooling combination layers. At last, after completion of this CNN part of the neural network, we have a flatten function. Now that flatten function is passed to any hidden layer, and finally, as per your classes you have that number of nodes into your final layer. Okay, now I have kept here two convolution layers, one of 2D, one pooling. In this way, two convolution layers I have, then I've kept a flatten, and finally there is one hidden layer and one final output layer. Okay, now my first COF 2D consists of 64 filters, and these are of size 3 into 3. Okay, and input shape, this input shape is the shape of my images, and my activation function is ReLU. After that, I've added max pooling layer. So I have used your max pooling, and I have kept the pool size of 2 into 2. Okay, then there's another COF 2D layer, but this time I've used 32 filters, and now I need to eliminate this input shape part. So I'm only keeping an activation function as ReLU, and after that I've also added one max pooling layer of pool size 2 into 2. Okay, so done with the convolutional part of my neural network. After that, what I'll do is I've added a simple flatten function. I've used the flatten function, and then I've kept a hidden layer of curates 104. Now this 104 number and the optimum number comes by practicing. Generally, a number more than 100 is preferred into after flattening the first hidden layer. So I've kept here 104. You can keep 128 or another number also, like 104 plus 8, maybe 112. Yeah, that way. Generally, multiple of 2 is preferred here. Okay. And last but not least, we have a dense layer. Now, as this is a binary classification problem, whether it's corona positive or not, I've kept last layer with just one unit, and I've kept the activation function as sigmoid there because it's a binary classification problem. Okay, so done with my convolutional neural network architecture. Now what I'll do is I'll compile my entire CNN model. I have kept the optimizer as Adam, not playing with the optimizers right now, just going with the most general one, that is Adam, loss as binary cross entropy, because it is a binary classification problem, and I've kept the metric as accuracy. Okay, so this part here is the part of my CNN architecture. Okay, now what I've done is after that I'm using image data augmentation for enhancing my results. Now what happens is that as you must have seen in the data set, the number of images we have is not much, right? COVID we have around like 38 images, and normal also the quantity should be same, is around 50. Okay, we have 70 here, and in COVID should be more. We have around 10111. Okay, so the ratio is fine. 70 111, around like 10:7 roughly. The ratio is cool, but the quantity of the images is certainly less. That just showing your model 180 images, will it be in a state to get some good accuracies? So what we'll be doing here is we'll be using image data augmentation for increasing the number of images, for adding different variations. So what generally happens is we do this augmentation with the help of image data generator class of Keras preprocessing, and we have here two options. The first option comes with flow from directory, and the other one is flow xy. Now flow from directory is used when we have the folders into two separate classes, like here we had COVID and normal. All the images are segregated into two different classes, so at that time we use flow from directory. And for example, if we had just one folder with the name of training set and all these pieces were jumbled up, so there we use flow dot flow xy. Okay, now here I'm using image data generator for augmenting my images. Okay, so I have kept the shear range as 0.4, zoom range as a 0.3, horizontal flip as true, and rescale as 1/255. So shear range is so shear is something like this, the shearing. Okay, if you must have studied physics when you were small, so shear is something like if this is my image, just imagine my image going in this way. Just you're fixating the bottom part, but you're moving the image. Okay, so that is the shear angle and all. Okay, then zoom, it is very self-explanatory, zooming and zoom out. Horizontal flip is the horizontal flipping you do to your image, and rescaling is the scaling of pixels. Okay, so with this different parameters, the number of images are augmented. Okay, and they are used into my training. Okay, similarly we do it for our test also. Okay, in test I have just used a rescale as 1/250. I have not kept shear range, zoom and horizontal flip because we don't need that much augmentation for a test. we need more for train. Okay, now keeping these parameters set, I have then use flow from directory. I'm passing the path of my folder where all my images are there. My target size is 64 by 64. I have kept the batch size as 4 and class mode as binary. Okay, then similarly I have set the values for my test also. Okay, I have passed the paths of the folders where my test and training set is available. And last but not least, I'm just fitting my classifier. Okay, I have kept the epoch as 5 for simplicity purpose. Then validation data is my test set, the folder where I have my testing images. Validation steps I've kept as 8 and steps per epoch I've kept as 40. Okay, let's do one thing. We'll train the model. So first we will just deal with the architecture part. Okay, after that we will play with the we'll do the augmentation part. Okay, and lastly we'll deal with the training. Okay, so definitely the epoch size should be more. 5 is not a good number, uh, but for video sake purpose I've kept it small. I've kept the steps per epoch also less and validation steps also less. Now as you can see, the accuracy is in first epoch it's very less, it's only 55.34, and the validation accuracy is really good. But slowly this you will see that the loss will go down and the accuracy will go up. Okay, at the end of fifth epoch we get a training accuracy of 91.73, and test is way good. It is around 181, 87, 7. It's way good. Okay, now we are done with the training part of a model. Now what we'll do is we'll take a unknown image and we will be passing it to a model and see whether it predicts out whether it's positive or negative. Now what I've done here is now see here, this image, it is COVID underscore normal. Now this image will be passing to our model and we'll be seeing whether what my a model tells whether it is positive or negative. So what I've done is I've picked this image from the training set only. In training set, if you see this, yeah, see this image. This image is very distinctive that this should be COVID positive only, because if you can see a large part of the chest is white, so it is filled with cough and fluids, and we are expecting that image should short be classified as COVID positive. Okay, I've kept that, I've copied that image outside, and here I am passing the path of that image, and then if my result is 1, it will give me normal. If not, it will give me COVID. Okay, and here I'm calling my classifier to predict what my image is. Yeah, so as you can see, my model tells me that it is a COVID image, so the prediction is right and it is being true to the accuracy which we have achieved into our training phase. Okay, so that's it with this video, guys. For a future enhancement, it would be really nice if you build a simple UI using Tinker, where you can just drop the image of any x-ray, and on the basis of that it will very intuitively tell whether it is corona positive or not. Okay, so that's it with this video, guys. If you like this video, give it a thumbs up, share it with all your machine learning, Python and ML enthusiast friends, and do check other videos of AI. We also have videos on Java, SQL interviews and all. Do check other videos also, and stay tuned to AS Learning for more such amazing tech stuff. Thank you, take care, peace out.